In this video I'm going to explain integration partial fractions. Here px and qx are polynomials and we are going to separate them into partial fractions. If you remember, this subject we studied when you were at 10th grade, and here there are some subtitles. Let's say px and qx with degree of the px is less than degree of qx. It's easy to understand these kind of things on the exercises. That's why directly I'm going to start with the exercise. Here I want you to remind about this kind of cases. Firstly, we studied this kind of cases at the integrating the logarithmic function, and if it is, let's say, integral of 1 over x dx, if it's equal to ln absolute value of x plus c, then integral of 1 over ax plus b dx, it's going to be equal to ln 1 over a ln absolute value of ax plus b, it must be plus c, of course. X plus b plus c, it must be. So if you remember this one, these questions, this type of questions, they are going to be easy for us, because here we have 3 over 5x plus 1, so it means that this is 3 times integral 1 over 5x plus 1 dx it's going to be. And I forgot at the beginning to explain this one, but let me remind you here about the degree of the qx is equal to 1. The degree of the polynomial, the power here, what is that? 1 is going to be, this is 1. And here we have x to the power of 0. That's why it's going to be equal to degree of qx also, not qx, px is going to be equal to, px is equal to 0. So degree of px is 1 less than degree of qx. In this kind of cases, what we are going to do, of course, here we are going to use ln absolute value of ax plus b method, and this is going to be equal to 3 times ln absolute value of ax here. Actually 1 over 5 times, it's going to be 1 over 8 was written, 1 over 5 times ln absolute value of 5x plus 1 plus c, it must be. And if you write one more time this expression, 3 over 5 ln absolute value of 5x plus 1 plus c, it must be. And here, of course, there is no term, that's why I'm going to write as 3 over 5x plus 1 only, not to confuse later the solutions. Okay, the second part, 2x minus 1, the power is equal to 1, and the 1 is 1 less than the 2, you know, it's equal to 2 minus 1, so the degree of this one 2, 1 less than, and we are going to understand that this is the form that we are looking for. And one more thing here, also we cannot factorize. When we cannot factorize, we are using this method also, cannot factorize. If we can factorize this one, we will use different methods for that one. Later we are going to learn that method also. Okay, then I'm going to use substitution method as usual. Here u is equal to x squared minus 3x minus 1, du is equal to 2x minus 3 dx, it's going to be, we should write in parentheses. So if I replace x squared minus 3x minus 1 by u, then 2x minus 3 dx, it's going to be equal to du. So this is going to be integral du over u, which is equal to integral here, of course I need to write this one, 2x minus 3 over x squared minus 3x minus 1 dx is equal to du over u, and du over u, 1 over u du we can write, and that's equal to ln absolute value of u plus c, which is equal to ln absolute value of u has chosen as x squared minus 3x minus 1 plus c is going to be. Okay, now in this question, in this type, not question, we are going to study about the reducible denominator. Here the terms of the denominator, there are two fraction here, there are two factor here, and with respect to this type of question, this values, we are going to solve our question, this type of question. But here we should remember from the 10th grade or 2nd grade, from the 2nd grade we learned partial fraction method. Partial fraction method here we should remember from the 10th grade subject, that one. Also I'm going to solve some exercises about this partial fraction method. Okay, the partial fractions, when we say, it can be second degree, here nth degree it can be, but the power form we have here, it's written like this. And the third one is one of the factor is linear function, the other factor is quadratic function. That this is and this cannot be we cannot factorize this one. And how to solve this kind of questions? It's better to solve this kind of questions on the exercises. Okay, 5x plus 7 over, it's already factorized here, there's no need to factorize, but we know this one. This is 3x squared minus 6x plus x, it's equal to minus 5x. Minus 5x minus 2 is the denominator here normally, and 5x plus 7 integral dx, this is, but this factorized like this, then it's factorized like this. And how to find the integral of this expression? Firstly, if you remember from the partial fraction method, we have to factorize this one like 5x plus 7 over x minus 2 times 3x plus 1 should be written in a over x minus 2 form times, plus b over 3x plus 1 form it should be. Then, as you know, this is in partial fraction method, we are trying to get the numerator same with common denominator. Then I'm going to first make the denominators common. So I'm going to multiply this one by 3x plus 1, and I'm going to multiply this one by x minus 2. But when you're multiplying by 3x plus 1, this expression, you should multiply by numerator also. So it's going to be a times 3x plus 1 plus b times x minus 2, it's going to be, and the common denominator I can write in one denominator, x minus 2 times 3x plus 1 it should be, and this is equal to 5x plus 7 over x minus 2 times 3x plus 1 it's going to be. Okay, now if the terms are same, if the denominators are same, we can do this one. Only if the numerators are same, we cannot do that one easily in polynomials. 5x plus 7, it's going to be equal to a times 3x plus 1 plus b times x minus 2. So 5x plus 7 is equal to, I'm going to distribute this term, 3ax plus a plus bx minus 2b it's going to be. And here the terms with x, they are going to we are going to collect them together. 5x plus 7 is going to be equal to 3ax plus bx plus a minus 2b it must be. Here the terms with the x, if I can write like this, 3a plus b x plus a minus 2b, this is the variable, this is the variable, and this is the coefficient of the variable, and this is the constant term. Here on the other side, when we have 5x plus 7, this is the coefficient of the variable, and this is the constant term. So 3a plus b must be equal to 5. 5 and a minus 2b must be equal to 7. If we apply the form here, system solution here, I need to write a minus 2b down. 3a plus b is equal to 5 and a minus 2b is equal to 7, and if we add them here, the second one, instead of adding, let me multiply first by 2, then I will add 6a plus 2b is equal to 10, it's going to be, and the last one, a minus 2b is equal to 7. Then 2a and 2b, if we simplify, 7a is equal to 17. Then a is equal to 17 over 7 is going to be 7. Then b is equal to actually a minus 2b, I'm going to use here a minus 2b is equal to 7. Then a is equal to 17 over 7 we found, minus 2b is equal to 7. So this implies that, or I can continue like this, minus 2b is equal to 7 over minus 17 over 7. 7 times 7, 49. 49 minus 17, it's going to be equal to 32. So minus 2b is equal to 32 over 7. And when you divide by minus 2, this expression will be b is equal to 32 over minus 14, because this is going to go to the denominator and we are going to multiply by 7, that one. So b is equal to minus 32 over minus 7 it will be. Okay, if we return to up again, a is equal to 17, a is equal to 17 over 7, and b is equal to minus 32 over 14 we found. And here I'm going to replace a by 17 over 7, b is minus 32 over 14, which means 5x plus 7 over x minus 2 times 3x plus 1 is equal to 17 over 7 over x minus 2 plus b is equal to minus 32 over 14, minus 32 over 14 over 3x plus 1 it's going to be. If you want to get the integral of this one, it's going to be equal to 5x plus 7 over x minus 2 times 3x plus 1 dx. It must be equal to integral 17 over 7 over x minus 2 plus minus 32 over 14 over 3x plus 1 dx. It must be totally dx. And this can be written like here. It can be equal to integral of 17 over 7 over x minus 2 dx, and plus integral minus 32 over 14 over 3x plus 1 dx. We can separate like this, and these coefficients may be written in front of the integral sign. So 17 over 7 is equal to 1 over x minus 2 dx, and plus minus 32 over 14 integral. This should be in parentheses because we are going to make the sign minus later. 1 over 3x plus 1 dx. In the previous page I showed the solution about the here 1 over ax plus b form. Here this both of them 1 over ax plus b form, so they're going to be equal to 17 over 7 ln integral, not integral anymore because this is ln form now, the integral has taken ln absolute value of x minus 2 plus ln minus 32 over 14 minus 32 over 14 times 1 over 3 ln 3x plus 1 plus c is going to be the answer.